week we talked about parallel lines. Parallel lines have the same slope. These two lines are parallel to each other because they both have a slope of -3. This line has a slope of -3. The second line has a slope of -3. Therefore, they are parallel. Okay? Perpendicular lines have opposite reciprocal slopes. So this line has a slope of 3/4. This line has a slope of -4/3. Again, the slope is the number in front of the x. They're opposite reciprocal. So when we flip 3/4, we get 4/3. One's positive, the other one's negative. Therefore, they are perpendicular to each other. Parallel lines, remember, they never intersect. That's why they have to have the same slope, because they have the same exact slant. They're never going to intersect. Okay? Perpendicular lines intersect, and they form what kind of angles? Right angles. So that's why they have to have opposite reciprocal slopes. Questions over that? What we talked about on Friday lesson. For example 5, it says write the equation of a line that is parallel to the line y equals 1/4 x plus 3 and passes through the point -8, 3. So we're writing an equation of a line. So I'm going to write it. Remember, we use point slope form when we write an equation of a line. It's like this. You're not given point slope form. You have to memorize point slope form. But you kind of get the process down. It's not so bad. Okay, so we're writing a new equation of a line. So we want to use that form. One important thing about our line that we're writing, it has to be parallel to that line. Well, ask yourself, what do we know about parallel lines and their slopes? They're the same slope. So what's the slope of our given line? 1/4. So what's the slope of our new line going to be? 1/4. So we know y minus something is equal to my slope, which is 1/4, times x minus something. Well, what we plug in is this point. Remember, the point is x, y. The y goes with the y. The x goes with the x. And then you clean up what you can. There's nothing you can really do with that one. Equals 1/4. We have a double negative, so it's going to turn positive. Again, don't solve for y. You don't have to solve for y. I encourage you to not solve for y. Room for error. Questions? Okay, so parallel lines have the same slope, so use the same exact slope from that equation. If we take a look at 6, this is write the equation of a line that's perpendicular to the line y equals 1/6 x plus 8 and passes through the point 12, -5. Well, again, I'm writing an equation of a line, so y minus something, something, times x minus something. Let's figure out our slope to plug in. If it's perpendicular to this line, what do we know about the perpendicular lines and their slopes? Opposite what? Reciprocal. Okay, so the slope of the given line is what? 1/6. So we have to figure out, because it's perpendicular, well, what's the opposite reciprocal of 1/6? -6. You flip the fraction. So when I flip 6/1, or 1/6, I get 6/1. The original is positive, the new one's going to be negative. And you can just write it as -6. If you leave it as -6/1, that's fine. So that's our slope. Once we plug in our slope, plug in your point. X and Y. What's going to go in this first spot? -5. What's going to go in this second last spot? Well, X goes with X, Y goes with Y. Clean it up. We have a double negative, so it's going to turn what? Positive. And again, don't stop to solve for what? Just leave it like that. That's totally fine. Questions over that? No. How can you use Desmos to check your answers? Let's say we weren't sure if we wrote this equation right. What could we do? Yeah, plug your answer and the original equation into Desmos. What we can do, the original equation was y equals one divided by 6 x plus 8. Plug in our answer, which was y plus 5 equals negative 6 times x minus 12. I have to search for it a little bit. But there we go. That's where they intersect. When they intersect, because they're perpendicular, what kind of angles do they have to form? A right angle. So use that paper trick. Again, if you put the paper in the corner, it should fit right nice and neat with those lines. So we'll have the red lines going along the edge, blue lines going along the edge of the paper. That's how you can tell if they're perpendicular. If you stick your paper in there and it's not fitting in between those lines perfectly, then it's not perpendicular and something happens. More than likely it's your slope. Check, it had to pass through the point 12, negative 5, because maybe you got the slope right, so the lines are perpendicular. It also has to pass through the point 12, negative 5. So plot that point 12, negative 5. So we made it so it's perpendicular. Is it going through the point? Is my line, my blue line, because that's the new one, going through the point 12, negative 5? Yes, I know I did it correctly. Because sometimes we get the signs mixed up in our equation, or we get our x and our y mixed up. So their lines are perpendicular, but it's not necessarily going through the correct point. So check both. Make sure they're perpendicular. Also plug in the point. Okay. If we check our answer with the first one, okay, our original was y equals 1 divided by 4 x plus 3. There's our original equation, the purple line. If we plug in our new line, we said y minus 3 equals 1/4 x plus 8. Oh, that's fine. X plus 8. Okay? Well, I know they're parallel because they're not going to touch, but it had to pass through the point negative 8, 3. And go to negative 8, 3, it passes through that point. So again, sometimes we write our points wrong in the equation. So when you just check, oh yeah, they're parallel. But it has to fit the criteria that it passes through the point. So also plot the point. Questions over that? If we take a look at this one, write the equation of a line that's parallel to 4x minus 2y equals 10 and passes through the point negative 1, 9. What's the problem here? Yeah, good. It's not slope-intercept form. How can we get it in slope-intercept form?
Minus 4x.
Yeah, if it helps, draw your line. Move that 4x over to the other side. So we get negative 2y equals, stick the 4 out in front, 4x, add the 10. Ooh, that was weird. What do we still have left to do? What do we need to do? Divide by negative 2, like you were before. Really weird. So get y is equal to negative 4 over negative 2 is what? 2. And what's 10 divided by negative 2? Negative 5. Now looking at this equation, what's this? Now that it's in slope-intercept form, we can find the slope. What's the slope of this line? 2. Okay. And I know my new, oh my gosh. I know my new line is parallel to 2x minus 5. So we know about parallel lines and their slopes. They're what? The same. So the slope of my new line, or my original line is 2. The slope of my new line is also going to be 2. And then you just plug in your point. What's going to go in this first spot? 9. Y goes where the Y. What's going to go in the second spot? And again, just clean it up. That's going to say Y minus 9. That's going to say 2. And that double negative turns positive. There's your answer. How could you have done this with less work? What could you have done? That's kind of a long-handed way. Yeah, just plug it into Desmos. No solving. Plug it in exactly how it is. Plug it in as 4x minus 2y equals 10. 4x minus 2y equals 10. And then once we plot it, how can we find the slope? Count it. That's all we need. We just need to know what the slope of the original line is. And we can count it using rise over run. So find those nice corner points and just do rise over run. We went up 2, so it's positive. We went right 2, so it's positive. So the slope of this line, from just doing rise over run, is 2 over 1. Just for you. That's the same slope we got for doing all this work in solving. So you can also just plug it into Desmos, count your rise over run to get your slope, and then you write your equation just like we did there. You get the right answer. It's less work. I don't care which way you go. Some of you just think it's easier just to solve it really quick and get your answer. That's fine. Some of you might think plugging into Desmos and just counting to get your slope. It's easier. That's fine too. Questions? Okay. If we take a look at example 8, line N has a slope of -2. Line N is perpendicular to line M and passes through the point 1, -3. Write the equation of line N. So they didn't give us an equation. Right? They just told us what the slope of the line is, and that's all really what we care about. Okay? We're writing a new line for line N. So I'm going to fill in my y minus something equals something times x minus something. And line N is perpendicular to M. And we know M has a slope of -2. What do we know about the slopes of perpendicular lines? They're opposite what? They're not just opposite. Reciprocal. So we have a whole number. What do we put it over? 1. What's the opposite reciprocal of -2 over 1? +1/2. Flip 2 over 1 to get 1 over 2. Change it to a positive. So that's our slope. What's it look like when we plug in our point? It has to pass through the point 1, -3. -3 here. What's going to go here? 1. Clean up your double negatives. And there's your answer. Again, you can check your answer. Plug this into Desmos. Plug the point into Desmos too. Make sure it passes through that point and is perpendicular to the given line. Plug the given. Oh, wait, sorry. Can't really check it. My fault. I forgot. They didn't give us the original line, so you can't really check this one with Desmos. Just have to trust that he did it correctly. If we take a look at this example, it says line J has a slope of 1/3, line K is parallel to line J and passes through the point -7, 5. Create the equation for line K. Well, I'm writing an equation of a line. Or oriented. If we know these lines are parallel, what is the slope of my new line? 1/3. Parallel lines have the same slope, so the slope of K is 1/3. That means the slope of K has to be 1/3. And then what's it going to look like? What's going to go here with the Y that has to pass through the point -7, 5? 5. What's going to go here? And again, clean up your double negatives. -5 equals 1/3. Questions over that? This one's a little different. Says line P has a slope of -2/5, and line Q is parallel to line P. Write two possible equations for both line P and line Q. In this situation, I think it's best to use slope-intercept form. You can use point-slope form. I just think it's easier to use slope-intercept form. This is a little less work than what I was thinking. Right? Because when we're dealing with parallel and perpendicular lines, all we care about is the slope. Don't really care about what the y-intercept is. Okay? So if we were to write two possible equations for these lines, they just have to be parallel to each other. Meaning, what do we know about their slopes if they're parallel to each other? The same. So line P is going to have a slope of -2/5. And line Q is going to have a slope of -2/5. Right? We just need to find a B. Or any y-intercept, it doesn't matter. Give me a y-intercept for line P. 2. So this could be +2. Give me a different y-intercept for Q. There you go. Those are two possible. You could have put -1,000 if you wanted to. That's one of them. You could have put -10 or -2. It doesn't matter what your y-intercept is. In order for them to be parallel, they have to have both a slope of -2/5. You could have used point-slope form. You could have written it like this, but you would have just picked any number for the y. You could have done this. This would have been totally fine. Where this could be anything, that can be anything, but that has to be -2/5. Your slope. That has to be -2/5. You could have written the answer like this. +20 equals -2/5 times x minus 72. That still would have been a correct answer. Okay. I just think y-intercept form is easier to think of us. But both are correct, technically correct. You don't have to use slope-intercept form. Questions over that? If we take a look at example 11, okay, we want to write the equation of a line that is parallel to the line graph below and passes through the point -3, -4. So I'm writing an equation of a line. I'm going to fill in kind of my skeleton. And we need to know the slope. How do we have to find the slope? We need to know the slope of the original line, but it's graph for us. Yeah, so we're going to count. We're going to do rise over run. When I do rise over 1, how far did I go? Went up 1?
One up, one down, and right 2.
Up 1, right 2. So our slope is +1/2. If they're parallel, what do we know about their slopes? So if the original line graph for us is 1/2, my new line is going to be 1/2. Fill in your points. What's going to go here with the y? Unit 4. It's going to go here with the x. Look it up. My double negatives are going to turn positive. There we go. Yes.
2 and 4.
Huh? Yeah. 2 over 4? Yes. It would simplify down to 1/2. But I'm pretty sure if you just left it as 2 over 4, it would accept it. Yep. Yeah, because it simplifies down. I thought you said 2 and 4. Took me a minute to think. So last one here says write the equation of a line that is perpendicular to the line graph below and passes through the point 2, 3. So I fill out my skeleton. Same thing as last time. How can we find the slope of that line? Rise over run. Here's my corner point. Here's my corner point. What is my rise? 3. What's my run? What kind of 2 though? Negative. Okay. What do we know about the slopes of perpendicular lines? Opposite reciprocal. So if I have 3 over 2, it's going to become what? Positive 2 over 3. The original one's negative. The new one's going to be positive. There's the slope of my new line. Plug in your point. What's going to go here with the y? What's going to go here with the x? There's nothing to clean up. No double negatives. So that is questions over that. Big thing to remember is perpendicular lines have opposite reciprocal slopes. Parallel lines have the same slope. Use Desmos when you can to check or help you get the right answer. No questions?